Welcome back to the Arduino series of videos. This is the third in the series. This time we're going to focus on analog write. It's actually not completely correct to call it analog write. We're using a scheme called Pulse Width Modulation to use something that's capable of putting up digital values, ones and zeros, 5 volts and 0 volts, to mimic an analog output. And this process is called pulse width modulation because we're changing the width of the pulse such that the average voltage delivered over time goes up and down. Let me kind of draw a little bit of a picture just so that hopefully would make a little more sense once you see the picture. So the pulse width modulation is talking about the idea where we would have it would instead, and so in the pin, in one of the pins that have squiggly next to it, I believe we're going to be using pin number 5 on the Arduino. This pin is actually digital, which means it can only put out, so this is pin number, it can only put out 0 volts, or you can ask it to put out 5 volts. Okay, so the pulse width modulation idea is that yes, you can put this pulse and we can do a periodic thing where it's high and low on a period. Let's say this is the period that is high and low and repeats itself over and over again as it goes. So the idea is that I can change the average power delivered, average voltage delivered over a period by changing the width of this. They typically refer to as on time. Okay, and typically they have something that we refer to in PWM as a percent or duty cycle, which is really a percent, and it's really the percent is calculated by taking the on time and dividing it by t. So when I say I have a 25% duty cycle, that means that 25% of the time it's on, the rest of the time it's off. If you average that, you will see that on the average in the period, instead of me seeing 5 volt, if it's 25%, I'm gonna see 1.25 volt, which is a quarter of a 5 volt. If I want to see 2.5, then I can change my on time to half the period or duty cycle to 50%. And then I see, so that's what's happening. Now I could do that. You could take a digital pin, write a little loop, wait, turn it on, turn it off. But the beauty is that Arduino processor has that capability built into it in certain pins. And in these pins, I can set up, of course, the pin has to be set to output. That's the first thing we got to do. We did that in the previous section when we were working on the digital write. And here, instead of saying digital write, we say analog write, and we give them a pin number and we give them a value. This value could be 0 to 255. So if you want this on time to be across the whole period, then we give them a 255, which means the average seen is going to be 5 volts. Okay, if you give them 0, that basically means the width of this on time is 0, therefore is 0 volts. So when is approximately 2.5 volt, it would be in the middle of this turn section, which would be roughly what, 100. If you put 127, 128 in it, then the voltage I'm going to see is going to be 2.5 volt. So this number indicates what average voltage comes out. So what does that mean? Many devices don't really see the high frequency changes, rather they see the average voltage delivered to them. So for example, if I have a motor and I want to slow it down, speed it up, I can just change that number and it speeds it up, slows it down. If I've got and we're going to use a LED, for example, here, because if I change that, then that LED gets brighter or less bright. So let's put some of these to use. I'm just gonna grab so you don't have to watch me type this. Oh, actually I can type this. This is not a big deal. So we're gonna bring this up and we're gonna say, okay, let's clean this up. I was doing something else, so let me get rid of it. Let me come back to that later. Okay, so I'm gonna come over here. Now remember from the previous one, we just had these output pins and input pins. All I'm going to use this output pin 5, and when we go back, you'll see output pin 5 has a squiggly on it, which indicates is capable of doing PWM. Not all pins are capable of doing PWM, okay? And then I left it, although I don't need it, I left it here, so later on I keep using the same piece to demonstrate different things, the piece of software program to demonstrate different things, so we'll just keep it here, okay? And I'll probably should, because it's no longer that, so we'll just clean this up. It's just an example. It's always a good idea. Oops. It's always a good idea to make sure that your comments reflect what is actually happening, which is one of the big issues with software. Comments get out of whack with this, what it's doing. But anyway, we get up here. We're going to leave this because we're going to need it for other things. So we're going to get down here in the loop, which happens over and over again, and we're going to tab it so everything is lined up. We're going to say analog and log write, and our pin is going to be the one we set for output, in this case pin 5, so I'm going to use the constant instead of writing 5 in there. And then I'm going to say, okay, what do I want to do? Let's set it at, let's say 128. That's about half power, right? So we are writing half powers, half the time on, half the time off into that one. And then we're going to wait, let's say a couple of seconds. And just to see if there is any difference, what I was going to do is going to just basically copy this thing, and instead of turning it completely off, I was thinking maybe take down to, I don't know, 32, and then do one more. And on this one, let's go ahead and set it to just 4. Remember, every number I put in here indicates it can be from 0 to 255. If I put 255 in it, then it's gonna make sure that is on all the time during the period, so it's just you get the full power to your device. I put it half power here, then here is whatever 1/8 of a power, and here I've had you know, much smaller, so I'm going down by a factor of 4 or 8 every time. And then and so I shouldn't really ever turn it off. So this what should do is should be half power, and then I don't know, 256 divided by 32 power here, about 1/8 of a power here, and then when we come down here, another 1/8 of a power down. So, and then back up to full power and all that. So what we're going to do, we're going to go back and set up the Arduino board. Let me plug this in as well. Let's go to the, all right, so let's position this so it's easier to see. If you remember from the last time, what I'm basically doing is, if I tilt this a little bit up so you can see, I'm going to take this red pin, it's in pin 5, goes to the long leg of the LED. From the short leg comes to the resistor, back to ground down there. So theoretically, this pin, we used to turn it off and on when we were doing digital, but now we want to see it kind of get brighter and darker as the time goes. So let's see if that happens, and see if I have any errors in my code. Okay, so we're going to look over here, and we see, okay, let's just make sure everything is okay. I'm going to write, wait, write 1/8 of the power, wait, write the 1/8 of it again, wait, and then start over again. So let's see how that works. Okay, so I'm going to compile it. Hopefully it all works. While this is compiling, I'm going to bring the camera up and minimize it so we can kind of, not minimize it, but make it kind of in the corner so we can see everything. Still compiling. The first time usually takes a little longer. Okay, it's done uploading, and let's see what's going on. Let's see if that is doing what we wanted it to do. So bright, that's bright, off, well, not off, but almost off, but 4 is almost off. And you can kind of see we are doing dimming. Now you can get really fancy with this stuff if you want. I had a little piece of code, and I wanted to take this opportunity to kind of walk you guys through the fact that you can do all of the things you normally do in programming if you're familiar with. See, this piece of code is supposed to work by dimming the light on and off. So let's write it in here. Instead of me having to manually put in every step, I'm going to let this guy let these loops do them. So in this loop, basically I'm saying, oh, okay, I changed the variable. Basically says for I equal to 0, as long as I don't go full power, I go to 64, which is, what's that, a fourth of the full power? 256 is full power. 255 is full power. This is approximately a fourth of that. And then I'm going to step it up by 2. So I start at 0, then 2, then 4, 6, 8. So every time it gets brighter and brighter and brighter. I'm waiting 200 milliseconds, which is 0.2, and then I do the reverse and come back down. So let's go ahead and compile this, and hopefully it will compile again. Okay, it's working on it. All right, now it's uploaded, and it seems to be working just fine. It seems to be working just fine. Uploaded it, all that. So let's go see what is happening to our LED. So our LED is sitting here, and you got to be patient, but hopefully you can kind of see how it's dimming down and back up full power, and then dims back down and back. It's all gone back again. So what we basically are doing here for this code is that we're basically stepping down until it goes to stepping up first to 64, and then slowly stepping down until we get to 0, and then this repeats itself. That's what that LED is doing. So here is a way of being able to give analog outputs, even being simulated analog works pretty well here. You can use the same technique, as I said, to control anything that depends on power and voltage, to be activated from heat to light to movement, like motors and things like that. That brings us to the end of another video. This one was focused on analog write using pulse width modulations.